In this video, we're going to cover the details for how to do a hypothesis test talking about the population proportion. So every time you start any hypothesis test, you want to set up your null and alternative hypotheses. And when you're doing them for the population proportion, it's your null hypothesis is always going to be p equals some number, and your alternative hypothesis is going to be either p less than a number, p greater than a number, or p not equal to the number. Now to figure it out, we read the problem and we're going to base it off of this example down here at the bottom. It says, based on poll results, a company determined that there was only 45% support for a new law. Since the new law would increase their profits, they started heavily advertising in favor of the law to try to increase public support. After their advertising efforts, they found a sample of 60 people had 32 in support. Test whether the advertisement has been effective at raising support using alpha equals 0.05 level of significance. So you have to read that and understand what they're saying and what they're trying to do. What are we trying to test here? We're trying to test whether the advertising has been effective. And so you have to read the problem and say, what did I mean? What did I want the advertising to do? I wanted the advertisement to make people like the law. So basically, I want to try to increase the percentage of people that want the law. So I'm saying that the default is it didn't work, nothing changed, and the percentage of people is still 45. But the alternative, that's where something changed. I was trying to increase that. So now I'm going to say I'm trying to prove that the percentage of people now is more than 0.45. One comment about when you're writing your null and alternative hypotheses for these, whatever number you use on the equal sign, you're always using the exact same number on the alternative hypothesis. So since I have 0.45 on the top, you're not going to try to think about some other number. It's going to be 0.45, guaranteed for the second part. The only thing you should be thinking about is it going to be greater than, less than, or not equal to? Now for the second question, it says we're going to have to calculate the p-value. And this is a huge deal. Let's talk about what the p-value is. So the p-value, this is the probability, assuming H0 is correct, that you would randomly get a sample as unusual as you actually got. That's a little bit confusing when we say it like this. Let me try to extrapolate on that. So let's say I'm talking about average adult male height, and I believe that the average is actually 5'8". That's what I believe my average adult male height is. And I take a sample, and the sample I get is 5'11". Now that is more than 5'8", sure, but I could have just randomly picked people and gotten an average of 5'8". My question is going to be for the p-value is, how unusual would it be that if the average really was 5'8", to get a sample of people that gave an average of 5'11"? Or in this particular problem, let's suppose that H0 is true, which means advertisement did not change anyone's mind, and it really is still only 45% of the population that agree with the law. And so now my question is, if it really is still 45%, what are the odds that we'd have this many people say they like the law when they were surveyed? Because it could happen. In fact, I could happen to pick a sample that every single one of them is in favor of the law. But that's just not very likely if there's only half the population who like the law, or 45%. So the question is how unusual is this going to be? And the thing is, once again, we're going to have a calculator function that's going to calculate this for us. It's going to do it really quickly here. And that's how we're going to get our p-values. Now you can do it by hand. You can calculate a z-score and use that z-score and the normal CDF function or the table to find a probability, and that's your p-value. You could do all of that, but it's going to be much easier to use a TI-84 calculator. So let's pull it up here and show you how it works. So on the TI-84 calculator, whenever you're doing hypothesis testing, the button you're going to use is the stat button. So you're going to hit stat, and then you'll see in the menu there it says edit and then calc and then tests. You're going to go all the way over to tests, and right here, this is where all of our hypothesis tests are going to be. All the different variations of hypothesis tests that we're going to do are all going to be in this. This is also, we saw before, the confidence intervals. See all these different things, but for this one, we are talking about proportions, and we are talking about a single proportion. So this is the one prop z-test. One prop z-test, and I hit enter. And it asks for P0. P0 is the probability, the proportion from the null hypothesis. And if I go back really quickly over here, the null hypothesis proportion, that's what this is. That's the 0.45. So I go ahead and put that right there, 0.45. Then I need to know what my x and n are. If you read the question, x was 32, n was 60. And then what am I trying to see? I'm trying to see whether it's bigger than the 45%. So I go over and select that one. It's the right tail test here. And then you go down, select calculate, and it's going to spit out the p-value. And you see right here, we have the p-value. It's the second one down there. I know it's maybe a little hard to see all these different things here, know what's what. The first line is the z-score. If you had actually done the work and calculated the z-score, it's what you would get. The bottom there is the n. We don't really need that. The one second from the bottom is the p-hat. That's what you do if you x divided by n. The only thing that we actually need from here is the middle number. That's the p-value, the 0.097. So p-value of 0.097 for this problem. What that means is there is a 9.7% chance that even if people didn't change their opinions, that we would have just happened to get a sample like this. Now go back to the very, very beginning of probability, and we said a certain event is something that had a 100% chance of happening, and an impossible event was something that had a 0% chance of happening, and an unusual event was something that had a 5% chance or less of happening. And the alpha is really deciding what we consider to be unusual. If you ever have a p-value that is less than whatever your alpha is, that means it's less likely to happen. That means it's more unusual. Then we say our sample is so extreme, it is so unusual, it is such a weird sample that there's no way our H0 was actually true. And we would reject H0. We'd say H0 is gone. I have now statistically proven H1. However, if you get your p-value, and in this case it's 9.7%, and that is actually more common than your alpha value, which is 0.05, well, that means that this is not a particularly weird sample. It's going to happen in roughly 1 in every 10 samples, like 10%. That's not very weird, so that means I don't have enough evidence to prove H1. And so we can write this several ways here. You can say there is not enough evidence to prove H1, or if you want to say that in terms of the problem here, there is not enough evidence to show the advertisements increased the popular support. Right? You could say the sample was not statistically significant. So the sample was not statistically significant. These are all words that you can say that are talking about the same thing here. Sorry. Was not statistically significant. I was going to write insignificant there, but I already put a not. So not statistically significant. So that means at this point in time, the company doesn't know whether the advertisements worked or not. There's not enough evidence based on this sample. This sample does not tell us that H0 is true. We cannot say that we now know the advertisements didn't work. All we can say is that this particular sample did not give us enough evidence to say they did work. And what they could do at that point is they could just take another sample and see if they can get evidence there. They could just keep trying more advertisements and try a different sample later on. There's different options for the company at this point. But at this point in time, it's just saying that the data we got wasn't able to really draw much in the way of conclusions. And this is unfortunately the kind of boring result where you can't make any dramatic conclusions. And one thing that as you read more about hypothesis testing and the current field of social sciences and just sciences in general is that when you get a result like this where you don't have enough evidence to really prove anything, that ends up being not very interesting. People don't want to read about that. They want to read these dramatic conclusions saying, I've just proven that this, and this. And so what ends up happening is these types of results don't get published very much. And if you look at journals, it's pretty much all results where they did prove something happened. And so what ends up happening is people try and they keep doing more and more experiments until they get something with a really small p-value so that way they can go ahead and try to publish based on that. And it's actually a problem because this is still useful information that the study didn't give us any proof. It's evidence saying that maybe H0 is true. I mean, it doesn't prove H0 is true, but it's saying maybe it is true. And if a lot of people did it and a lot of people got the same results, then you'd be more likely to believe H0. So it's still good information to have, even if you can't make a direct proof out of it. And yet a lot of these things essentially get thrown away. If a study happens like this, they won't even bother trying to publish it because it likely wouldn't get published. Anyway, so that's kind of a side topic about these things here. But this is the details on how we do hypothesis testing for population proportion.